welcome to our day 2 of L'Hopital's rule. What we have done previously in day 1 is we finished this section above here with those forms, and now we're going to be doing the third form of LHOP. So LHOP has 3 different types of forms. We got the 0 over 0, infinity over infinity. Those are great because we just take the derivative and then top and bottom, plug in. If it works, great. If not, keep going until you can plug it in. For these up here, these indeterminate forms, you have to rewrite it so that you can get a 0 over 0 or a infinity over infinity. So these aren't too bad to rewrite. Usually it has to deal with the trig or fractions. All you gotta do is make it into one fraction or just flip some trig. This last one right here, these forms are going to be 0 over 0, or sorry, 0 to the 0, infinity to the 0, or 1 to the infinity. And these are a little bit trickier to get into a 0 over 0 form or infinity over infinity form. So let's go ahead and tackle these problems right now. So if I plug in an infinity, sorry, not infinity, a 0 into here, I'm going to get 1 to the infinity, which is one of these forms. So what you're going to do here is you're going to let y equal 1 plus x to the 1 over x. Okay? And what you're going to end up doing is you're going to rewrite this so that we can play around with this a little bit. So the one technique we do know is if we take the ln of both sides, then we can play around with this a little bit. Okay, so we're going to take the ln of both sides. So let's go ahead and see what this is going to look like when I start working from here. So let's let this y equal the limit as x approaches 0 of 1 plus x 1 over x. When I take the ln to both sides, I'm going to get ln of y equals the limit as x approaches 0 of ln of 1 plus x to the 1 over x. Now the whole reason we do this now is so we can put that 1 over x out in front. So ln of y is going to equal the limit as x approaches 0 of 1 over x. So I'm just going to put this into the fraction like this. So that turns into 1, the ln of 1 plus x all over x. Now when I plug this in, I'm going to get 0 over 0, and that's totally awesome because now I'm ready to LHOP. And make sure that we do recognize that these are arrows and you have a 0 and a 0. If you don't put these arrows or recognizing that you're able to do LHOP, then you won't get full credit for it. So now when I LHOP it, I don't know why stays there. I didn't do nothing with that. But I'm going to get the limit as x approaches 0 of the derivative of ln of 1 over x is going to be 1 over 1 plus x all over derivative of x is just 1. So making this look a little bit cleaner, we're going to get 1 over 1 plus x. Okay, am I ready to plug 0 in now? I sure am. I'm going to get ln of y equals, plug in a 0, I get 1. Now, remember, y is going to be my answer. So I want this to be, I need to solve for y. Once I solve for y, then that's what that answer is going to be right there. So what I'm going to do here is to get rid of the ln, you have to do e to the ln of y and e to the 1. So you're going to do e to the ln of y equals e to the 1. So it gives me that y equals e. And this is just a log property that you should be somewhat familiar with. So this is our last type of form. Again, for LHOP, quick recap is just let y equal this, which is started to do over here. I just showed this work just to show you that, hey, we can play around with it a little bit. And then go through, and then at the very end, whatever answer you get there, you can get e to the, so that we can drop that y back down. And if you actually remember from an earlier set of notes in the archives, we actually said that this was a formula, right? This was a formula that did equal e. So there you are. Not a long video whatsoever, and that is the third form of LHOP.